All right, let's take a quick look at solving logarithmic equations. Now, when we were solving exponential equations, you notice that a lot of times to solve it, we would take our exponential and turn it into a logarithm, kind of undoing the exponential. Well, how do you undo a logarithm? Well, to undo a logarithm, you just turn it back into an exponential. So take a look at this guy. So on this guy, I can rewrite this as base 10 to the fifth equals x plus 1. 10 to the fifth equals x plus 1. And we're almost done. Subtract 1. And boom, that's it. Okay? Now, sorry, minus 1. There we go. So easy peasy. But then we get a problem like this. And I go, I can't convert that into an exponential because I have multiple logarithms. Well, in our last lesson, hopefully you remember that we took those logarithms and we combined them. Okay, we condensed them into one logarithm using those properties that we have. So like this, if we're subtracting two logarithms with the same base, we can rewrite it as this quotient here, okay? Natural log of x plus 1 divided by x. All right, so now we can rewrite this as e to the third equals x plus 1 over x. All right, I can multiply x on both sides. Move my other x over. I can factor out my x. And now x is almost by itself, but I'm multiplying here. And that winds up being our answer. Now this is a little tricky again. Let's walk through that one more time. So we're subtracting our logarithms, so we turn that into division inside the logarithm. Then we rewrote it as an exponential. We multiplied x, so we wouldn't have that in the denominator. We moved all of our x's over to one side so that we could factor out the x. And then we divided. Now, there's one more thing that we technically need to check on all of these. So a lot of times we will go all the way and we'll solve all of this, and then we'll realize that actually this statement was impossible, because you have to make sure that we're plugging in positive values for x. Now, if I plug this in, this will give me a positive value. So plus 1 will also be positive. So this turns out to be a valid solution. All right. Let's take a look at this one. Now, this one's a little different because we have logarithms on both sides. Some people would think that would make that more difficult. It's actually going to make it less difficult. You'll see why in just a second. But our first step is going to be the same. I've got multiple logarithms on this side. I want to condense that down into one. So since I'm adding the logarithms, I'm going to multiply these guys to condense that down into just one logarithm. All right, so now we have log 2 of this, log 2 of this. Well, if you remember earlier, I gave you problems that kind of looked like this. And we said, oh, if they have the same base, then the exponents must be the same. We have that one-to-one property. Well, the same thing is going to be true whenever you have two logarithms with the same base that are equal. These are going to be equivalent. Again, as long as your base isn't something crazy like 0 or 1 or -1. Okay? So from here, I can just make the statement that x plus 1 times x equals 3. And now I just have a quadratic to solve. Now, again, here, this could be quadratic formula, this could be whatever. I think I can factor this. No, maybe not. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. So 1 plus 12. There we go. And we have two solutions for this equation right here. But again, we have to check and make sure that x plus 1 is going to be positive and that x is going to be positive. Well, it turns out this guy right here is going to be negative. So that guy is not a solution. But this guy is positive, so this will be a solution. All right? So let's walk through that one more time. I combine my logarithms together. Once I have logarithms with the same base on both sides, I can set their contents equal. Okay? These have to be equivalent. Then I work it out. I make sure that all of my solutions are valid so that when I plug them in, I'm going to get reasonable numbers there. All right, let's do one more. Similar concept here. So I combine this into one logarithm because these were added, so I wound up multiplying the contents there. Since these are logarithms with the same base, I can conclude that their contents are equivalent. Should be minus 15. Again, this is just me moving everything over to one side. I don't think you can factor this, so this is quadratic formula again. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. I believe that's 60, so this will be 61. So this is our solution right here, except we have to double check that everything is going to be positive in all three of these. So I know this one is going to be negative, so that's going to cause all of those to be negative, so that is not valid. Let's check this one just in case. Square root of 61, that's going to be about 8. Minus 1 is going to be about 7. This is going to be about 3.5. This minus 4 is going to be negative. There's no valid solutions to this equation. So again, work this out. Make sure that all of your solutions wind up being valid. Because again, if I put something close to 3.5 here, that's going to be negative, and that is invalid. So that's how you solve logarithmic equations.